I'm trying to find. Did I submit?
You don't remember?
I don't know. It's not even showing it submitted. Wait. No.
All right, now class, some people email me, and it could have been the other class too, about the Visual Studio and whatever. Oh, I didn't know I was supposed to use Visual Studio. Either one, you can use either Visual or Online GDB. But when you submit your assignment, I got one or two, and like I said, I just graded a few. Some people email me their their CPP file. I want it submitted. Everybody understand that? When you submit your .h, you're supposed to submit the .h and the .cpp together. Everybody understand that? I shouldn't have to look on a different date or a different time for the other file. Both of the files should be there so I can pull them in and do what I need to do. Right? Everybody got that? All right. So now let's look at online GDB right quick. Because I think some people still have some issues. So if I pull up online GDB, all right, I told you to write the program. All right, well, you got two to write. But the one, the first two, which was the bonus ones, well, basically, you had to just type them in and get the bugs out. All right, so this would be our main program. How many people had started using the solo learn? Nobody? All right, I want you to start go online whenever the weekend, whatever. Register with the solo learn, it's free, and then go through the different little chapters. It's gonna help you in your coding. Everybody got that? Now, hopefully, I want you out.
Yes, sir, I gotta go.
All right, so I want you to complete all those different chapters in the first part of that solo learn. All right. How you doing? Good. All right. So if I had a program here, say int x equals 5, whatever, y equals 3, whatever, total. All right. And then I have something like total is equal to x plus 5. So all we're doing is declaring two variables to equal to some value, and then we assigning it to a total, all right? And then I can output that, see out total, all right? All right, so we're outputting total. So this program by itself will just run and give you that, correct? We'll give you what? Total? Oh, I put 5, right. I should have put y, which this was right, but that's not what the program was written to do, right? All right, so x plus y, and that should give me 8, all right? All right, so we have 8, right, class? Now, what I told you, every program that you submit, I wanted you to create your own header file with your class information, all right? Course name, your name, the title of the project or the assignment, my name, and the due date, right? Now, so how would you do that? You would have to create another file. Now, here, you would give it a name, whatever name you want, all right? But it would be easier for me if everybody gave the same name, but I don't want you to be caught up in programming, saying that, oh, it has to be this name. Everybody understand that, all right? So a lot of times when teachers teach, we teach you to follow a certain pattern, and then students, you get stuck in that same pattern. You can have a file name, a header file name to be whatever that you create .h, right? So, but I would want you to call it header, all right, .h. Well, when I pull it in, and then when I'm doing things, I don't have to say, okay, what's going on? Oh, he changed his to this. Oh, she changed hers to this. All right. So that's the file name. Now, when I create this header file, if I'm I have to, I'm gonna click in it. Alright, I have to in this header file, if I'm doing CNC out, I have to do my pound include IO stream, or pound include, friend. Alright, then using namespace, almost like I'm writing another program. Alright, and now I don't do main because main is in what? The CPP program. Everybody understand that? Main function is in the CPP program. So here I could create any function of any name that I choose. What's the rules for user defined variables or identifiers?
No special character.
No special character. Huh?
And no spaces.
Can't start with a number.
Can't be given a number and no spaces, one word. So you can create anything. You could do something like void, and you could say, all right, that would be valid. You got what I'm saying? One word, doesn't be given a number, no special character, right? But what's the function name? Baton Rouge. You got what I'm saying? This is just the for the argument list, all right? And we were passing variables back and forth, all right? Well, passing variables and what we call them, all right? But Baton Rouge is the function, all right? So I'll just change this to head. All right, now I would create it just like I create my main, right? I would not put what? Semicolon at the end of here, and now I would put all my little cout statements, like cout my name, cout whatever. So I do cout and whatever I'm gonna output, I'll just say name, all right? Cout course. Cout project, cout instructor, and cout. All right. So, and then I might say, okay, I'm gonna double space before I start anything. So, this is some information. This is valid statements, right, in the C++ program. So what happens is, this is created. So when I go back to my main.cpp, I can remove this because this will be loaded from what? From the header file. So I can do what? In double quotes, I can specify my header, all right, .h. Now, so what's happening? When it executes this CPP file, it's gonna say, wait a minute, they have specifying a header.h file to be loaded, kind of like any one of your man IP, IO stream, whatever, right? String. So what happens, it goes, look at here, and says, okay, it's loading IO stream, right? User namespace for this, and then what? It's defining a function that I can call and use in my program. So now when I go to my program, it knows that head is a valid function that I can call. So if I wanted to call it before I output this information, I'll simply do this. And it's gonna what? It's gonna know that header.h was a header file that was loaded. Head was a function defined in header.h, and now I have access to execute or call that function, right? So now when I run the program, what's going to be the output? Huh? Right, and then my what? Result of 8, x equal to 8. So when I run it now, see? It printed name, course, project, instructor, due date, right? And then it executed the program itself. But it went out and what? Retrieved that header file, and then found, we called the function head, it executed what was in there, and then it continued with the program itself. Everybody understand that? Okay. I want all my programs to run like this. When I go to Canvas, I want to see whatever .cpp file and a whatever .h file, and hopefully a header.h file. Okay? Yes, ma'am.
All of them got to be header.h.
I would rather you do it, but it's not a rule, but it'll make it easier for me when I'm pulling it in. I know I'm referencing, oh, that's their header file. But then some people might have some long name or some other name or whatnot. If everybody use that same name, yeah.
Does it have to be .h? Because I made mine header.cpp.
No, .h. I think .cpp will cause an issue. Let me. I could run it, but normally you want to load because pound include you're loading a .h file. You understand? So I could try to rename this and see, but from my knowledge, I call it CPP, and then I'll go in here. I will tell you. So if I run this, should get an error. See? You understand? Because that header file should be .h. That's the extension for loading headers. All right, or headers to be loaded. All right, so it got to be .h. Right? All right, and that's the distinction between the two. Because the most CPP files, you have a main function in it, right? All right, so change this to .h. All right, and change this to .h. All right, now. So everybody squared away with that. So now let's look at our, anybody got questions about the assignments that was assigned? Questions? Hello? So I'm gonna get my assignment. Speak now. Huh? Are you straight? Okay. All right, I'm gonna pull this up. All right. Good morning, Miss what? Last name?
Arvina.
Oh, Miss Arvina. All right. All right. So class, you got a string program, 2 string programs. Remember we talked about what? Escape sequences, right? I'm just trying to get you familiar with using those escape sequences, all right? I want my output just like it is. All right, my 20 commands. Well, no, this is the string program. The string program, one of them, you're initializing the values and outputting it. The other one, you're allowing the user to input the value to output. And I got some notes in there in red. When you're gonna be inputting your values, you're gonna have to what? Load the string library, right? And use the getLine function, right? So you gotta pay attention to those. And then these other programs, this program's gonna add this and determine whether or not these inches is so many feet and so many inches. Everybody understand that? Everybody know how to do that? Everybody gonna research how to do it, right? All right. And the next program, basically, we know that 2a is equal to what in math? 2 times a, right? So if a was a value, if a was 3, that would be 2 times 3, which is what, 6. 4b is like saying 4 times b. 3ab is like saying 3 times a times b. Everybody understand that? 5a is like saying 5 times a. And 2b is like saying 5 times b. So what you're gonna have to do is take this expression and write it out so that the computer can understand it, but you're gonna give a value and give b a value and let it solve that expression. Everybody understand that? Okay? Right? Example, if a was 0 and b was 1, what would the results be? Huh?
X again?
If A was 0 and B was 1, what would be the result? Yes, oh,
1.
1?
-1.
All right.
-2.
Look at that. Because what? 2 times 0 is what?
0.
Huh? 0. 4 times 1 is what? 4, but it's negative, right? So we have a -4. 3 times 0 times 1 is 0. Alright? So we still have our negative what? 4. Then we got 5 times 0 is what? 0. So we subtracting 0, but you can throw that away. Then we got 2 times 1 is what? It's 2. So 4 minus, -4 plus 2 is what? -2. So everybody understand it solved that expression, right? How to solve that expression. Everybody see that? All right. All right. So let's get to the chapter. Any questions? All right. I want my assignments, right? They was due last night. Okay. All right.
No,
Or tomorrow.
they do tomorrow.
Okay. All right. Y'all should be working on them right now, right? Not procrastinating, not waiting. Ain't that right, Miss Russell? All right. So, let me open this. So let's complete our chapter because we started on our chapter 2, and there was some information that I wanted to cover with you
Oh,
in this chapter.
too much work.
All right. So we talked about the decimal notation, correct? We talked about that in this class. I got my 2 classes. The assignment statements, the bool data type. The other class, right? That was Monday. All right. So, all right. All right. So let's start with identifiers, because we did talk about identifiers. So let's start here with identifiers. And what happens is an identifier, which is user identifiers. We just talked about it, about the different rules. What were the rules for the user-defined identifier? What were those 3 rules? No spaces, which is 1 word. No special characters, and cannot begin with a number, right? So, all right. So if you look at the table 2.5, it shows you some examples of some valid identifiers. All right. You got day of week, where O is capitalized and week, W is capitalized. So that's somewhat camel case, right? But then you got 3D graph. That's what? Incorrect, because it started with a what? A digit, or a number. But now, sometimes students get confused with this. You see the underscore? The underscore is a valid character, all right? You can use underscore. Now, sometimes it depends on the compiler or whatnot, but for most cases, the underscore is somewhat used like the characters, all right, like the letters. All right, so you could write a variable, create a variable, something like total underscore pay underscore for underscore the underscore month underscore of underscore January. You understand? And you'll see just that underscore in between the different spaces, where you can almost like read out the variable. All right, June 1997. That is valid because the numbers are what? After the first digit, correct? But look at the other one. Mixture, pound 3, all right? Some people say #3. What happens? That's a special character. $, special character. Double quote, special character. Everybody understand that? You cannot use special characters in the variable name. Most of them have some type of meaning in the compiler. All right. Now, Alright. So, we have different data types, right? We have char data type, right, or character data type, but we have integer data type. Now, we normally use what? Int. We just say, okay, int. But there is short int. Short int is still integer, but it only takes up 2 bytes, right? Now, what that does though is allow you to use less memory in your when you're compiling a program, but the size of the number that it can hold is a lot less than the what? The size of a int. Everybody understand it? Okay? The thing is, this is the range for short int. In short int, if I had a number, 3,000, well, x was equal to 32,767, and then I added 1 to x, what would x be? Well, when I output it? Once I add 1 to it, and it's equal to 32,767, what would x be? Huh?
32,766.
All right, let's go here. Let's write. Let's somewhat write it, right? We'll say short, right? Short x equals, what was that value? 32,000? No, not here. Yeah. What was that value? 32,767. All right, 32,767. All right. Now, if we do this, okay, x plus plus. What we doing here? We'll get to what that actually means. But what we doing when we do x plus plus? We adding 1 to x. So now x really should become what? In realistically.
32,768.
Right, that's what it should be. But if we saying we're using a short data type and the largest value can be 32,767 and we increment it, what will happen? What it does, it just loops back to the beginning and starts giving you the negative value working its way back up. So the value will be what? A negative 32,768 because the 2 bytes, I only can put values from the negative extreme to the positive extreme, and that's it because of the byte size. Okay, so when I run this program, all right, and I say cout x, and notice we done added 1 to x, right? And watch when we run it. See what we have? See what the answer is? Now, but if I just simply do what? Change this to what? Huh? If I change short to what? Int, right? When I change it to int, now I'm making it possible to be from a negative what? Million, billion to a positive to the 2 billion, right? So now what happens here is when I run the program, if I change this to int, everybody understand that? So the different data types that are different data types that you use can affect your results. Everybody understand that? You could be like, oh man, I know my program working. I worked it out, and I went through it, whatever, did it by hand, whatever. I checked my code, whatever, and it's not giving me errors. It's working, but it could be what? That you're not allowing for enough byte size so they can hold the values that you're working with. All right, so you gotta be mindful of that. Now, like I said, the reason why you pretty much want to do that, if you know you're working with numbers less than this and greater than the negative 32,000 whatever, then you would want to use short because what? You're using up less resources, right? right? Less memory and whatnot, maybe programming faster, etc. All right? So, yeah. All right, so if you see short int, 2 bytes, take up 2 bytes. Unsigned, but now what happens? Why is this number larger? Because what happens is when you have a sign on a number, it has to take up a position. But when it's unsigned, that means you won't have a negative or a positive symbol, so now you give it that extra byte for that extra position for that number to be stored. So that's why it can increase the size of the number if you do unsigned. But when you do unsigned, everything you get will be what? Will be what? Will be what? Positive. You can't get a negative number. Okay? You can't get a negative result. Everybody see that? When I use unsigned short int, I can have a value from 0 to 65,535, but it's only gonna be positive, right? Everybody got, because the sign won't be able to be stored. All right, now, and then like I said, you got your others, int, 4 bytes, unsigned int would be a little longer, long int, 4 bytes, then you got unsigned long int, then you got long int, all right? I'll give you a capability to deal with numbers of these sizes, all right? So like I say, you could always go to a chart like this to see if you would have to, like say, use a different data type in order to, for your program to calculate its value, okay? All right, and then this program has variables of several of the integer types, all right? So we got int for checking, unsigned for miles, so miles can only be positive, all right? So, and then long for days. And so checking is -2. If I did unsigned int miles, unsigned int checking could not be what? Negative, right? So, and then it's printing your information, giving you back the information. So like I say, you could use those different data types also, all right? But normally outstanding, we normally use int, or like I said, depending on size, we can use short, all right? Now, everybody know, and like I said, hopefully like the program I gave you, everybody should know how to write code and output it to where you can output stream text. You can stream text and you can stream the value, stream text and stream the value, right? Intertwined. Everybody understand that? All right, without being confused. Look here. This will see out the Grand Hotel has, and then space. Then it's going to stream the value for floor. Then it's going to stream the word or space in the word floor and a new line. Then it's going to stream the word it space, and then it's going to stream the value for rooms. Then it's going to stream space, rooms, and space, and then it's going to stream suite. We should be able to understand this class. If you don't understand this, you need to practice it over the weekend because stuff we're doing, you have to know how to format the output to be legible and understandable to a user. All right? All right. And now it just goes on to show you how you can really do long int without having, long amount. And then when you want to store the value, you could put 32L, and that's saying, okay, that value 32 will be placed in amount as a long integer. Okay, so you can do, and then you got LL, and you got the same thing for your float. Okay, now all this is saying is, if you plan to continue in computer science, you will be dealing with octal and hex because a lot of addresses you'll see, especially when you deal with pointers, you have addresses and whatnot, and if you want to actually access or know what that address is, where it's at, you'll be dealing with hex. So, programmers commonly express values in numbering systems other than decimal, right? And we did that in our 192 class, converting from decimal to binary. Binary and binary to octal, octal to hex, all right? And binary to octal also. So, now, So it tells us, by default, C++ assumes that all integer literals are expressed in decimal, all right? But you can change that. It says, here's how a hexadecimal number F4 would be expressed in C++. All right, so what happens is when you put the 0x in front of it, you're saying that, hey, I'm representing this hex value. All right, and then octal numbers, you just simply be preceded with a 0. All right, so for example, the octal 31 would be written as 031. All right, so those are some of the little things that C++ does. Now, character data. Char data is what? When I say char letter, I'm dealing with how many characters?
8 bytes.
How many?
1.
One. If I say char letter can only equal to 1 character. Now, if I try to assign letter to equal to a particular character, I have to put it in what kind of quotes? Nope. Single quotes. Has to be in single quotes. Otherwise, I'm saying, if I put it in double quotes, I'm saying it's more than 1 character. Everybody understand that? Has to be single quotes. Later on, we're going to see what happens when we do use double quotes, or what happened with string data. All right? So look here. Char letter. If we wrote this in our program, we done allocated a space for a variable called letter. Then letter equals G, single quotes. Now we've assigned the G to the variable letter. It's stored in that memory location. All right? So, but here, if we do this, letter is equal to double quote G, we created an error, or we're going to have an error in our program. And the reason being, and I'll scroll down to hopefully to show you right here. Look what happened. If I store something using single quotes, it stores just that what? Single value. When I put double quotes, automatically the computer's gonna have to put a backslash n, a backslash 0, which is a null terminator. All right, it's a null terminator. It terminates the end of a string. If the null terminator is not put at the end of a string, the compiler does not know when to stop printing the string. So when we do char letter, this is the only thing we can put, and it has to be in single quote. When we do double quotes, it's gonna try to put both of these, and you got an error, right? You're trying to force two different bytes into that particular data type. Everybody understand it? So you have to use the single quotes when you use char, right? Now, when we're dealing with a char arrays, that's gonna be different, okay? Because you can have an array of characters, all right? But we'll get to that later on. So now, look at this program. This program creates a variable called letter, all right? Now, it says letter is equal to A, C out letter. It's going to put what? A. Then letter is equal to B. It's assigning letter to equal B. What's actually happening at this point?
It's changing.
It's doing what?
Changing it.
Correct. It's going into the memory and says, okay, where's B? Where's the memory address for B? Oh, what's in there? Whatever's in there, take it out and override it with the letter B. All right? So now you've just overwritten your value that you previously had. So now when we output letter, it's going to output what? B, not A. All right? Everybody got that? And this would be output. But remember in 192, especially in my class, we would try to stress to you that don't try to deal with numbers and letters, how would I say it? Like char and int. Don't try to deal with them, together. Wait till you start actually programming to understand. So now what happens is, now we're gonna understand that I can have a char variable, okay? And I can assign it to an integer variable that's an integer variable and print out the decimal value of it, okay? So what happens here is char letter, right? So letter can only equal to what? a character, right? When we print out letter, it should print out what? A character. But within the program, we saying letter is equal to 65. 65 by default is a what? Is a number, an integer. So what it's gonna do is gonna go look at the ASCII table and say, okay, what is 65? 65, the letter is, the character value is 8. So it's gonna store what? Well, it's gonna take a letter and assign it to be 8. So now when I output a letter, it's gonna output 8. Alright? Then letter is equal to 66. Alright? Then it's gonna say, okay, what's letter? Output letter? It's gonna output B. Alright? And really, kind of misquoted, because when you do this, when you really do this, when you say letter is equal to 8, it doesn't store the 8 in the letter address. It stores the 65, you understand? And then it says, okay, I'll output it, I'm gonna put the chart there. Alright? So in here, when I say letter is equal to 65, okay, it's storing it, and then when it prints it, okay, it's an integer, but okay, find what that integer is, let's print it out. Because we did look at the ASCII table, right? And that ASCII table has all those keystroke values. Alright? Alright, and look here, this is all what it's saying. The letter A is equal to 65 in decimal. So when a letter is 65, it will print out A. Alright? B is 66, alright, in the ASCII table. So what happens is when I assign letter to equal 66, it's gonna output B, the char value, B. Alright? And the same thing for C, and moving on up. And uppercase and lowercase characters have different values. Alright? Every single character has its own unique value. Alright. What's the difference between string literals and character literals? Alright? Remember we talked about that null terminator. But it says it is important that you do not confuse character literals with string literals. Alright? Strings, which are a series of characters, right? Your name is a what?
A string.
Your school name is a
String.
You understand? Multiple characters, right? But just the one letter can be what?
Character.
Char value, right? One letter. It can be a string also, but it can be char, right? But this means that there must be some way for the program to know how long a string is. And like I say, the way they do that is with this null terminator. If you wrote a program and you did this, but then too, if I'm going to use string class, I have to load my what? String library, okay? Your program will not work without that. So if I do string name, all right? I'll say string name is equal to BRCC. Now, what happens is the string is BRCC, but the compiler will automatically add the null terminator for you here because it see that as a what? It's a string of characters, and it automatically puts it. So that what? When you output name, it's gonna output B, R, C, C. Oh, null terminator, I'm finished. All right? Because without the null terminator, it'll just start reading those consecutive memory locations, and now you might get what? Garbage, until it finds a what? Null terminator somewhere in that in your memory. All right? So that's what happens. Now, so it tells us that in the last byte, the number 0 is stored, all right? Well, really \0, all right? It is called the null terminator, all right? And it marks the end of the string, okay? Don't confuse the null terminator with the 0 character. See, it's almost like an escape sequence, right? \n represents one character, right? \\, represents one character, right? So the 0 and the \0, that's two different things, all right? Now, so if the word or the name Sebastian was to be put in a string, it would automatically add the backslash 0 so it'll know the length of that string. Alright? Now, and look, so I could store A, and we talked about that, but when we store A with the double quotes, it has to have what? Multiple positions so it can load the what? Or store the what? Backslash 0, which is the null terminator. Alright? So, and as you can see, the A in single quotes is 1 byte, whereas the A in double quotes is 2 bytes. Alright? Alright. And we'll look at some significance after that. So look at this. This A, it stores just the number 65. But the A with the double quote stores 65 and then the 0. So it knows that, okay, that backslash 0 is going to be the end of the output. All right? And it tells us, look at this. Char letter, we can only assign it to be what? A with the single quote. Cannot do what? The double quote. All right? So, looking at this. Char letter, see out letter, A, letter, B, assigning B, see out B. Basically the same thing. All right? Assigning it the letter A, and outputting, assigning it the letter B, and outputting. All right? Because then it says, let's review some important points regarding character and string. Printable characters are internally represented by numeric code. What they're saying, when I store the A, it's going to store it as what? 65. All right? When I store, if it was in double quotes, it will store the 65, but then it would store the backslash 0, which is now. All right? Okay. All right. And then normally characters normally occupy a single byte of memory. All right. And these are some of the things that you need to know. Now, the C++ string class. All right. So, what? The pound includes string. Without this header file loaded, you cannot declare a variable to be of string data type. You cannot do it. All right. But look, just like I am having the program string name, they have string movie title. So now, once I do that, I could assign any string of any length to what? Movie title. Because what's going to be put at the very end once I finish my string by the system? That null terminator with the backslash 0. Right? So no matter how long it is, it's going to put that backslash 0 and you'll know what it is. All right? So look what happens. String, movie title. Then it's assigning Wheels of Fury to movie title. But then look, see how my favorite movie is space, and then it's streaming movie title, which would be Wheels of Fury. All right? Because it's going to know when to stop, because it automatically puts the null terminator. All right? This program demonstrates the string class. And if it does, we should see what? Pound includes string in our program. Right, class? Without that, you'll be fighting all weekend or whatever, trying to do a program and wondering why it's giving you an error. All right? And basically, that's basically the same thing we looked at above. String, movie title. Movie title equal Wheels of Fury. See how my favorite movie is, and string movie title, which is Wheels of Fury. So that's all that is, basically the same thing. All right? So you could go over those questions here. Floating point data types, all right? That's dealing with decimal. And look, it shows us decimal notation, which we should understand. And also, if you've been dealing with numbers in chemistry and whatever, when you do a lot of equations, they don't try to go all the way out. They'll do scientific notation, right? Well, you know what? 10 squared is what? Really what? 100, right? So it's like me multiplying this number here by 100, right? But scientific notation takes a number, leaving one significant digit, and then doing the multiple of 10 or 10 to the whatever power plus or minus, right? But if you go negative, if I have 0.001, then that's what? 1, 2, 3. That would be 1.0 times 10 to the negative 3, because I have to move my decimal place back 3 to get to the decimal value to use it, right? All right. Now, E notation, basically the same thing, you're just not using the 10, but then you're doing E2, all right, 10 squared, 10 to the negative 4, E minus 4, all right? So that's just E notation, all right? Represents the number same way, but you know that you're gonna be moving a decimal place to the left or the right so many spaces, all right? And you need to get familiarized with that to understand it. All right, because like I said, a lot of times when you write code or you're developing software, you might be working with a scientist, a chemist, or whatever, and you're gonna have to kind of know these math, the functionality of math, so that you won't have to go and try to learn it just to go and write the code. All right. So, talking about the keyword. Everybody should have saw the keyword table that was in the chapter, right? Am I giving you all the keywords assignment? But in the chapter, you should have saw what? That they had a list of all those keywords. And then you can go online and find out what they actually do. All right? All right. So in this program, it's just showing you how they took this information. Distance is this, right? Mask is this. But look how it's represented. E notation, E notation. When it outputted sun, it's still the E notation, right? Plus 11. So that means wherever the period is, you moving to the right 11, right? And if you gotta add zeros, you need to add your zero to represent the full number, all right? And then the same thing for this one. This is E30. So that means what? 30 positions out, right? Class not over. Huh? Oh, you scheduled something. All right. So that's E notation. All right. Now, remember how we had when we was able to write a number and put the L at the end to say, okay, we're putting this in or storing this value as a long int. See, we could do the same thing with float. All right, where we could put an F, all lowercase f, and we're putting it in as float. All right. So see here, the same thing here. All right. You can suppress the warning message by appending the F suffix to the floating point literal, shown here. So when you do that F, you're saying, okay, I'm putting it in as this float, all right? Or as float. Here again, long. Now, notice, this L here, now we know we got long int, but this would be long what? This would be long what? Huh?
Double.
Long double because we got a decimal. You understand what I'm saying? If it was an integer value, we know it can be what? Long int, right? But being that it has a decimal in it, it's long, double, right? Huh? All right, a whole number is what type of number? Integer, right? Number 5, that's an integer, right? So if I put an L at the end of 5, I can say, okay, force it to be long int, right? But if I put 5.02 and put an L, what I'm telling the system? Long what? Double, because it's a decimal.
So double for a decimal.
Right, you understand? Right. You understand? Got it? Okay, all right. So it would be the long double. And notice, capital or lowercase, doesn't matter. All right? Assigning floating values. And like I say, sometimes this is where some students get caught up, because like we say, you can assign a decimal value to an integer variable. Right, class? If I said int x, right? And I said x is equal to 10.5. What's stored in x? What's going to be stored in x? Huh? Miss Whatever, what's going to be stored in x? Oh, me, yes, ma'am. No, X is integer.
But you can't do that because.
Yes, I can do it.
But you just said if it's an integer.
Okay, look at that number, 10.5. Is there any part of that number representing integer? Huh?
Yeah.
All right, so the computer gonna says, okay, I'll take the 10 because it's integers, but I'll throw away the rest. You understand? So watch, let me show you the program. So if I do this, I'll say int x, and then I'll say x equals 10.5. What's gonna be the output? 10, because what? It's gonna try to store 10.5 in the x, but it's gonna say, oh, x is integer. The allocated space for x is int. I can only store an integer value. It won't give you an error. It's gonna just say, okay, it's a number, so I'll just take the integer part of that number and store it. So when I run this, you understand? Just 10. Got me? Now, there's a program normally that's written that asks you to determine if a number is odd or even, right? So, what they normally do is, there's many different ways. What they normally do is say int x, all right? All right, and then they would say cout enter number, all right? So now, cnx. Now, and then you would do something like, it's not the time, huh? All right, int x, int y. So here I would say, all right. So, and now you're gonna see something that if all right. I'm gonna say the number is equal. All right. So what I've just done is, all right, look here. I mean, x int and y is int, all right? You got it? Now, so I'm inputting a number, correct? Then I'm taking that number, dividing it by 2, and multiplying it by 2, all right? Now, if I get the same number, then the number should be what? Even. If I don't get the same number, it's what? Odd. Now, why would you say that? If I divide 5 by 2, what I'm gonna get? Dealing with integer, I'm gonna get what? I'm gonna get 5, divide 5 by 2. What you get? When you divide 5 by 2, what you get?
4.2.
Dealing with integer.
2.5.
Oh, only
Oh.
2.
Yeah.
Right. 5 by 2, you get 2. Times 2.
Oh.
Right. You understand?
And it's not 5. So.
Right. You got what I'm saying? So that's normally what happens. And I think this should work. Because it ain't gonna put the terminating character. What I did.
I see what's come out.
You got a
Right,
double
but
quote on
yeah.
line 12.
Yeah, I'm missing it up. Yeah.
Yeah.
I'll put it. Yeah. So let's run it again. Take that warning out. Then I still got CNX. Oh, stream. All right. So let's run this. Now, so I put, like I said, I put in 5. You understand? Nothing, because I didn't have anything for odd, right? But let's run it again and give me an even number. Give me an even number. 4. The number is even, 4. You understand what I'm saying? But 5, it didn't give you any results because I didn't have the logic to give you anything. I could have said else number is odd, but you got what I'm saying? So when you when you store a value into an integer variable, whether it's decimal or int, it will only take the integer portion of that number and throw the rest away. All right? And you gotta remember that because you can't be writing code and coming out with wrong answers and you're like, man, what's going on? Why, whatever? Huh? Oh, okay, up there.
Oh, let me take a picture too.
I need to minimize. I don't have the header file showing. Because at the top you got this. Alright. Alright, so class. Now, a bool value, alright, like Boolean value, that's 0, 1, yes, no, true, false. So if we look at this program here, what happened is when they define or declare a variable to be a bool, alright, bool value. Now look here, it's equal to true, right? And then they can set it equal to false. So it can be equal to true or false, which would in turn be 1 or 0. Remember the little if statement I had in the program just now? When it was gonna execute that line to say the number is even, it equated to be 1 because it was true that it was an even number. But when it equated to be 0, it was false. It didn't do anything. You understand? But that's that bool value, true, false, yes, no, on, off. You understand? And sometimes you need that in your program when you're running code, you might want something to be turned on, a switch turned on. So you could use on. And if something is false, you say turn it off. So it's going to only have 2 values, on, off, true, false, yes, no. All right, a bool value. All right? Now, determine the size of a data type. All you can do is use size of. Now remember we said the size of an integer variable was 4 bytes. Watch. We could do this. I could do on the side of this, I could do all right, size of x. All right. So x is a variable, right? Of what data type? Int. Int is normally how many bytes? 4 bytes. So now when I run this, I need to put some space here. When I run this, I should get, I put a number, so I'll put in 100, right? See, 100, but look, what that 4 represents? The size of x, which is the byte size used to store the value of x. So that's some keywords or that's a reserved word you can use in your program. Find out what float, long int, because some compilers may have the sizes may vary, okay, depending on the compiler or the system that you're running it on. All right. Now, I got about 5 minutes, right, Claire? Right. All right. Yeah, and we gotta go with the scope. Is this the end?
The longest chapter ever.
Man, we need to go over that.
Good.
Longest chapter.
Yeah,
ever.
what we'll do, we'll have one more class period, then we'll have a test. Because like I said, I'd like to go over the lesson with you. All right, so let's go back up. We were dealing with where was I? Then I might have went too high. Oh no, I'm right. Scope. All right. All right. All right. Assignments and initialization. Class. Look at this. And sometimes students get confused with this. All right. Look right here. What am I doing at this point in the program?
Initializing the variables.
I'm doing what? Let me ask you this. What initializing does?
Names.
Huh?
Names.
Huh?
Names.
Initialize.
Tells what it does.
No,
Declares the name.
no.
That's the.
Initialize, give it a value. You understand what I'm saying? It gives it a value. You know, I could say, okay, X, int X. What's the value of X? You don't know. So it don't have no initial value. Right? So all we doing at this point with X and Y is doing what? Declaring them. We just allocating a memory location so that we can store a value. Right? That's declaring. But if I do this, then what? I'm doing what to X?
Assigning a value.
Huh?
Assigning a value.
Which means, what I'm doing? Begin with an I.
Initialize.
I'm initializing it. I'm giving it that starting point. You got what I'm saying? So that's initializing. So what I'm doing to Y? Y? What's Y?
Why declare?
I'm just declaring Y. You understand? Y is just given a data type. That's it. No value. So it's just being declared. X is being what? Initialized. Now, let me ask you this. If I do this, what I'm doing to Y?
Initialize.
No, you initialize when you give it the data type and the starting point.
Declare.
I'm assigning. All right. So you got to beware when I give an assignment and I say declare X, Y, Z variables, then assign the values, whatever. But if I say write this program initializing the variables to be, that's different. Right, class?
Yeah.
Assigning and then so you gotta be aware of that, right? So when you do it, when you're giving a data type, that's initializing. At the start, when you're introducing it, you're giving it size. But if you done allocated the space, gave it a data type, no value, but later on in the program you give it a value, now you assign it. It could be an expression or whatever, right? Now, but remember that though. All right, so here, unit solved. What we do? Solve on the right, assign to the what? Left.
Solve on the right.
Always. It's not like math where you can switch it around. Everybody understand it? You can't switch it around. Look here, 12 is equal to unit solved. You can do that in math, right? And still solve. You can't do that in computer science. Okay? That's a key point. All right? So what's happening with month and days here? What are they doing to them? Initializing the variables, because they giving them their value when they give them the data type. Right. All right? So now, declaring variables with auto keep. All right? Now, I don't never use it really, but what that does is you can say, okay, auto amount equals 100. 100 is a what type number? Integer. So the computer will say, okay, well, it looks like an integer, so I'm gonna just assign it of integer. Now, when you I write code like say PHP code online. PHP, you don't have a data type. You understand? But what happens is the system looks at it and takes it and do whatever. If I say, if I introduce a variable, normally I'm giving it a value. And what it does, it takes that value, it equates and they say, oh, it's a string, then I'm gonna use it as a string. Oh, it's a float, oh, I'm gonna use it as a float. Oh, it's an integer, I'm gonna use it as an integer. That's how most programs do it now. Like when you're doing designing stuff on the web. You don't have to say int or float or char or whatever, right? But like I said, what we're doing, we have to give our data type and whatever, right? All right, next class period, we're gonna start on scope class. The scope of a variable is very important. What that is when you're working with C++, yeah, hold up, I'll let you go. When you're working with C++, you have your main function, your body, right? Open curly brace, close curly brace, right? And if I have something like this, I'm gonna reduce this. if I have this, and then we gonna go, if I have this, int x equal 5, anywhere in that scope, x gonna be equal to what?
5.
Unless I change it, correct?
Change, right.
Now, in this, what happens here, I can have a different scope, right? So all of a sudden I have a different scope here. And in this scope, I can introduce a variable, and normally when I'm using like a for loop, like I say, let me show you. All right, so what happened here? I use x again, right? But x gonna be used in what? This scope. You got what I'm saying? And when it breaks out of this scope and returns back to the main, what's its value gonna be?
5.
Bam. You understand? So that's what scope, dealing with scope. You can use that same variable in different scopes, but when you leave out of that level, it returns back to that original value. So and that's something we're dealing with and working with, because you can get very confused and, man, why my value is this? I know I said x to this, and why? But when you went that scope, it changed. When you came out, it returned. So you don't know, what's happening. All right. So review your information, do my assignment, and we'll continue starting the scope on next class period, and then we probably have a test after that. Okay. But do my work, though. All right, do my work.
Hey, look at this. I got something to say.
No, I didn't put our test together. Oh, you didn't tell one?
Well, the one that talked about, just like ramp, when I first time I took my test,
Well, we know we do. I do makeup. I do something else. So you know, you know how to do the makeup.
Yeah.
All right. Where you been?
Huh?
test.
Taking what test?
Your test.
That's where it was all coming from. It was all coming from your test.
From feeling my test.
No, I passed. 72.
Ooh.
Yep.
You know.